All right, for this problem, we want to factor the polynomial. And so when we look at this, f of x is equal to x to the fourth minus 3x to the third plus 6x squared minus 12x plus 8. You could think about maybe trying to group or do something like that, but there's 5 terms. Normally when we group, we have only 4 terms. So then it makes me think about just looking for the possible rational zeros and then testing them to try and find one, and we can use that to slowly break up this polynomial. So possible rational zeros are found by looking at the factors of our constant term, so the factors of 8, over the factors of our lead coefficient, which in this case would be really a 1. So we're going to look at plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, all over plus or minus 1. So really these are our possible rational zeros. And so I'll start by just picking 1, because that's nice and easy. That's possible. And then remember, we take all of our coefficients from our polynomial here. So we'll have a 1, negative 3, 6, negative 12, 8. And I want to test and see if any of these are, or if this 1 is a 0. So I want a remainder of 0. Let's see if that happens. Might get lucky on the first try. So put a 1 down here. 1 times 1 is 1. Combine these together, we get negative 2. Multiply again, we get negative 2. 6 and negative 2 make 4. Multiply again, we get 4. That's a negative 8. Multiply again, we get negative 8. And woohoo, we get a 0. So what that means then is that 1 is a 0, which comes from the factor x minus 1. And then the rest of these numbers here are the coefficients for our leftover polynomial. So we're going to be at x to the third minus 2x squared plus 4x minus 8. And so if you remember the last term here, that's our constant. Then we stick an x, and then we go x squared, and then x cubed. So this is me factoring that function, f of x. And so I want to see if we could factor it more. So now looking at what's left over here, there's 4 terms. I would want to try and factor that by grouping. So the first 2 here, they have x squared in common. Pull that out. I'm left with x minus 2. For the next 2, they have a 4 in common. I factor that out. I have 4. And I'll be left with x minus 2. So I know that the factoring by grouping is working because these are the same factor. So I'll pull that out. And then x squared and plus 4 will be what's left over. And then I have x minus 1. So the first thing I wanted me to do is factor this over the set of real numbers. And so when I look at this, I can't factor x squared plus 4. That is not the difference of 2 squares. There are some zeros associated with it, but they're going to be complex zeros. So right now, this right here is factored over the real numbers. So if I want to kind of keep going, and that's factor over the complex numbers, that means really I want to have all linear factors. So you can see this is x minus 1, x minus 2. Those are linear factors. But then this x squared. So how can we break that apart? Well, let's check out what the zeros are. For me, that makes it kind of easier. So I'm going to subtract the 4. So x squared equals negative 4. Then I'll square root both sides. We're going to get x equals plus or minus. Because it's a negative inside, we're going to have an I, and the square root of 4 is 2. So we'll have plus minus 2i. So under the complex numbers, I'll still have x minus 1 as a factor, x minus 2 as a factor. Now I'm going to have x plus a 2i and x minus a 2i for my other factors. And so for my final answer, factored over the complex numbers, that's what I would have. And so overall, just to keep in mind, my zeros are going to be 1, 2, negative 2i, and positive 2i. So hope that helped.